So we're asked to find the marginal revenue for a given production level. That's basically saying that Q is the production level, the quantity that needs to be produced. Um, and what we're given here is the demand equation. This is the quantity that would be demanded at a certain price. So marginal revenue, by definition, is the rate of change of the revenue. So that means we need to find first the revenue function for this given function. Okay, and it says find it for the given production levels. That would be different than if it had said find it for the given price. Basically what this is telling us is that we want to have Q as the input value for the revenue function. If it had said find the marginal revenue for a given price, then we would have P as the input value for the revenue function. Either way, revenue is defined to be quantity times price, price times quantity, whatever order you want to put it. Since we're taking Q as the input, we want to have everything in terms of Q. Okay, and that's why it says here, hint, solve the demand equation for P, and then use this revenue equals Q times P equation. So anyway, the first thing we want to do, solve the demand equation for P. So we'll do that first. Here's our demand function. We're going to solve this for P. So that means we want to move this 100 to the right, to the left side, move the Q to the right side. So we're going to get 100P is equal to 9,000 minus Q. And then we'll divide everything by 100, so we'll get P is equal to, if I divide 9,000 by 100, I'm going to get 90, and then minus, if I divide this by 100, I'm going to have 1 over 100 Q. Okay, so then I want to use the equation revenue is equal to price times quantity. Price times quantity, where P, this is the price function now, just the demand function solved for P. So we'll plug that in for P, 90 minus 1 over 100 Q, and then we have the Q right there, and then we'll distribute the Q to both of these, so we get 90 Q minus 1 over 100 Q squared. Okay, and then we want to, so this is the R function. In fact, we can now even call this R of Q, since Q is the input value. This is R as a function of Q. And then we want to find the derivative of this, R prime of Q. Okay, so we just take the derivative of this function, put the 2 down in front, so that's 2 over 100, that's the same as 1 over 50 Q. And then it says, let's go back to the problem here, it says find the marginal revenue for the given production level. The given production level is 500, so we'll plug in 500. I'm going to find R prime of 500 for this problem. Okay, so we plug in 500, we get 90 minus 1 over 50 times 500. Okay, 500 over 50, that's just going to be 10, so we'll get 90 minus 10, so 80. Okay, so the marginal revenue when Q is 500 is 80, and we can interpret this answer. I guess there's no units given here, so I'll just say 500 units. So we can interpret this to mean that the revenue is $80 on the 501st unit. Okay, so that's the way that really anything will work: marginal revenue, marginal profit, marginal cost. It's whatever it is you're talking about on the next unit after that. So basically, for this one, again, if we manufacture 500 units, then the 501st unit that is sold will bring in $80 just on that particular unit. So again, marginal revenue basically the revenues that you're going to bring in on the next unit after the one that you're plugging into the function. Okay, $80 on the 501st unit in revenue.